So we'll go ahead and get started. I'd like to welcome you to our workshop on Git Basics. I'm Jesse Spencer-Smith, and I'm Chief Data Scientist for the Data Science Institute at Vanderbilt. And today we're going to be doing a number of different things. We're going to, first of all, talk about why you may even want to use Git. Then we're going to have a Git and GitHub overview. This is going to cover, what is Git? What is the difference between Git and GitHub? What's a remote repository? And how do the two work together? Then we're going to get some a real look at Git working. So we're going to do this first using a graphical user interface. We're going to be using the GUI, which is embedded in RStudio, but it works pretty much the same way, whatever GUI you use. And then we're going to do some hands-on command line Git. If you got the email before the workshop, then you might have taken the opportunity to install Git if you're on Windows, or to learn how to get to your command line if you're on Windows or on Mac. If you didn't, or if you couldn't get it to work, don't worry. We do have two technical assistance rooms that are open with Dr. Sharo Bell and also Umang Chowdhury, who are data scientists at the Data Science Institute. But again, you can also just continue watching, and even if you're not able to code along with me, you'll be able to watch the recording later after you get everything straightened out. So don't worry if you couldn't get it to work. You can simply watch and then try it on your own a little bit later. So let's start with Git and GitHub overview. And I'd like to start with some horror stories. So I'm interested in horror stories that you have about a time when you made some changes or you did some work and then you lost it. So in brief, and if I can put someone on the spot, Sharo, can you think of an example where you thought you had something and it turns out you didn't?
Yes, I have a fantastic example of something that happened to me during a software engineering class. We were working together on this great GUI project that had to do with tracking routes from a researcher. And I was going along and I was making all these great changes and it was fantastic. And I was like, okay, I've done my part. And then come to find out I had deleted like this really important part of the code for rendering. And so it was really hard to be able to understand where that was without the versioning.
Good horror story. I have chills already. That's a good one, especially when you're on a team. Anyone else? Go ahead and raise your. You can turn on your video and raise your hand, or you can add it in chat, and be happy to call on you so you can share your horror story. I will share a horror story that I had. So I was working on, working on a large project, and surprise, surprise, it was on deadline. So this was for my undergraduate computer science degree. And I had written an abstract algebra system where you could do some basic abstract algebra interactively. And I was working late at night because I had to make the presentation the next morning. And I decided to clean up the code because I knew that I'd have to turn in the code and I just wanted to make it a little bit cleaner. So I did, and it didn't work at all. And I had no earlier version of it. And as a matter of fact, it never worked again. So I went off on slides that I had created, hoping that they wouldn't actually ask me to make the code work because I was out of time. I had to run and make the presentation. And luckily the presentation was enough, but there was no way for me to go back and figure out what I had done wrong and to roll it back. We have a good story here. Email project midterm, it was working. Yep, here we go. Yeah, the cleanup kills you, doesn't it? We removed experimental code, restarted the kernel, and realized you had installed libraries and declared variables out of order. It was broken and no reference point. That's a great one. Thank you, Aaron. Eva, I just began my software engineering journey 2 months ago, tried to create a branch, but didn't know how to switch back to the main or push to the new branch. Yeah, it can be scary when you don't have a good overview of how things are working together, because you don't know what you should do, and you don't know if you do the thing that you think you're supposed to do, who it's going to impact. So what our goal for today is to get you an overview so you can get a sense of what's happening, when, and why. So today I want to introduce you to the high-level concepts, and then I want you want us all to be able to see what these look like in practice, and even get to the level of you creating, if you don't have one yet, you creating a repository and doing a clone of it, meaning bringing it local and actually going through the whole cycle one time while understanding everything that was happening. So that's our ultimate goal if we can get there. So this we're going to be running from 11:30 until 1 o'clock. For about that last half hour is when we're going to be really the hands-on. And again, if you don't have Git installed, don't worry, you can watch and then try it on your own a little bit later. So one of my favorite XKCD comics here. This is what versioning looks like when you try to do it with the file name, which kind of works, but then you end up with something along these lines. There's always a little bit more work that needs to be done. Okay, so why use Git and GitHub? Well, actually, these horror stories tell us why. We need to have versioning. We need to have a good way to version and to figure out what we changed, when we changed it, so we can go back when we've cleaned up our code. We want to unwind those changes. We want to be able to go back to a working version at all times. We want to track changes and their intent. How many times have you looked at some changes that you made in code and you wondered, what was I thinking? Now, if it was a good change, you'll start with, what was I thinking? Let me think about this for a little while. And then let me say, oh, about 45 minutes later, that was a good idea. When all that you would need is have a little idea of why you did it, and then you could have saved yourself all that time. We want to be able to share these changes with others without having to send all of the code over. We want to be able to telegraph those small changes that we've made so they can understand what we're up to. Maybe we just want to save our work in a safe place, not on some USB that we're going to be losing. Maybe we want to combine change with others, with changes made by others. Maybe we want to track the work that needs to be done. These are all reasons to use Git and GitHub. Maybe we want to estimate the work that remains on a project. Maybe we want to test out additions before they become included in projects. These are all great things. And between Git and GitHub, we can accomplish all these things. So if you look, what we have here is all of these are accomplished really by Git. So Git gives you these. GitHub gives you these, working in concert with Git. And finally, these additional things are also part of GitHub, but they're part of the ecosystem that we've talked about in the last couple of weeks. So you can see all of these work together, and it's just a matter of understanding, our role here is to understand what's happening with Git and exactly how it works with GitHub. So let's think about changes, and we can think about this first, almost like versioning in Google Docs. So in Google Docs, you'll do some work here, and then you will, the changes will be saved. And at any point, you can go back to a prior version, but you can only go back to points in time. And that's what the versioning looks like in Google Docs. So there are a couple of things that you can't do. You can't say, try some experimental changes, and then at a later point say, hey, those changes were a good idea, I'm going to pull them in. So you don't have branching. And also, you can't do something along the lines of, oh, I don't like what I did here, but I want to keep what I did here. It doesn't work like that. You can go back in time, but that means you lose everything in between. So in Git, what happens is each time that you make a change here, you're actually creating a snapshot of what your work looks like. So you have a snapshot. It's highly compressed, and it creates something that's called a hash. But the hash is a fingerprint of the changes that you've made. The hash acts like a name for the change that you've made. So each time that you do that, you get a new snapshot and a new fingerprint. The other thing that you can do when you do this, and this is called making a commit, is that you can also have a message, a commit message. A commit message allows you to put just a little short statement about what it was that you were trying to do. And usually what we try to think about when we're doing a commit message is to say in our mind, with this work, or with this commit, I did something. So what is it that you did? And that's what you want to put in your commit message. So once you do that, with each of these different snapshots, an interesting thing that Git can do is it can do diffs. So let's say that we wanted to be in this situation where we want to get rid of this. It can use the differences between different versions and then recreate versions that borrow from different parts. So if you want to roll it back, if you want to get rid of a much prior commit, like here, you can do that. And then you can even keep your more recent work because it figures out what you did then, and it figures out what you did later, and it simply creates a new version that doesn't include that line anymore. So it doesn't include that, but it includes the subsequent work that you did. So that's generally what we get with Git. Git is local on your machine. Git has the following components, and now we're going to sort of walk through what it looks like. Actually, before we do that, what questions do you have so far? You can put them in chat, or you can raise your virtual hand by clicking on reactions, and I will unmute you. All right. So let me ask you, what's one of the first things that you do when you start a project? So someone gives you some work to do. What's one of the first things that you do? Yeah, brainstorm. All right, give it a, yeah, motivate. Absolutely. Look at the goals. Yeah. So you give it a name. So when you give it a name, are you simply putting it on a piece of paper, or are you doing something to create a place to put everything? What are you naming? Exactly. So most often people create a folder with a good name, and that's what we have here. So in the green here, this is our folder. So this is our directory. So that's often the starting place. What we're going to find out is there's even a better starting place, but we'll talk about that in just one moment. So in this folder, you have all the files that you've been working on. We're going to call that the workspace. That's what you see. That's what you edit. What Git does is it creates an additional hidden file in that subdirectory that's called the repository. The repository is saving all of the commits that you make. So it's not a picture of your entire workspace. Instead, you decide specifically which files you want to version. And every time you version those files, it adds another entry as a commit within the repository. So the regular file folder is still there, but there's a special file underneath that has a compressed snapshot of the different work that you do. So you remember that I said just a few things in there. So you actually want to be able to say what you want to include and what you don't want to include. If you think about it, you might have some scratch files that you don't want to include. You might have some work that you're not quite done with yet and that you don't want to put into the repository yet. Can anyone else think of other kinds of files that you might not want to include in the repository that you don't need to version? Ooh, that is really great. Oh, so VJ, restricted access, data files, data that you don't want, large data files, absolutely. All of those are great examples. So why not put protected information into your repository? Well, in a minute, we're going to see that a natural thing to do with your repository is to make a remote repository in GitHub, which everyone might have access to. And wouldn't it be kind of embarrassing to expose lots of people's social security numbers to the general public? Actually, yeah, no, that would be horrible. So yeah, that would be something you don't want to have in the repository. Large data files. Remember, you're getting a snapshot each time of the files that you are committing and changing. You'll probably need to save those large files elsewhere because that's going to make that repository blow up. So we don't want that. Binary files. Binary files usually come from being compiled from source code. And again, they don't really compress very well. They're already binary. So, and they're sort of almost always secondary files. They came from somewhere. So rather than versioning the end product, you version the source code instead. Source code is small, it compresses nicely. And actually, that's what people are going to be doing. They're going to be using the source code to recreate and recompile. So no reason to save those binary files. API keys, also great example, kind of private information. You don't want to share those. So you want those, you want to control what goes in. So how do you control what goes in? Well, you say add. This is the staging area. The only things that are going to be put into the repository first have to travel through this staging area. And how do you tell what files you want to stage? You say add, and then you give the file name. And that says, it doesn't do anything other than sort of add it to the list. So when you get to the point where you say, okay, now I'm ready for everything that I have mentioned here in the staging area, I want to go ahead and stash, I want to put that into the repository. That's when you make the commit. The commit takes the snapshot of those files. So what happens here when you do the commit? You get the snapshot. You get the hash, which is that fingerprint. And if you commit with a message, which you should always do, you also associate that, you associate that with a message. And then that gets stored in the repository. Okay, so how does remote work with this? Well, this is great for solving those high-level problems that we were talking about before about versioning, but it doesn't solve the problem of how you share with others. To share with others, what you want to do is you want to take this repository and you actually want to have a remote version of it. So it's not that you want to have the workspace saved up here. So this is not the same thing as Box. Okay, this is not the same thing as Box. Instead, you want to only have the repository communicate with the other repository. So you want to make a copy of the repository, have it sit in a remote place that other people could see. And if other people make changes to that repository, you want to be able to get those changes by having your two repositories communicate. Because you remember, everything is stored as a commit and everything has a fingerprint. So this is a great way when other people make changes for you to see what those changes are and then weave them into your work. That's what the remote repository allows you to do. So we have add when we're ready to, when we've made changes to a file, when we've touched files here, we've done something with them and we're ready to add them in. They go into the staging area, then we make a commit with the commit message, we put it into the repository. And when we're ready, we can do a push up to a remote repository. We can also do a pull. So we can actually do a pull and we can say, all right, has anything changed in the remote repository? Go and have the two repositories communicate. Let me update my repository. And then in the background, really what you want to have happen is for those changes to also be implemented in your workspace. So if somebody made a change to a particular file, yeah, you have your repository updated. You also want to have your file updated in your workspace. So this is actually, I started with push, but actually what you really want to do when you go through this cycle, and you might go through this cycle a couple of different times, and then you're saying, I better update my remote repository. I've done enough work now that I want to let people know what I've been up to. Actually, the first thing that you want to do is you probably want to do a pull. What have other people been up to? So you do a pull, and then you see if there's any conflict between the work that you've been doing and the work that they've been doing, and you can settle that. We're not going to be talking about that today, but that is handling merges. So the first thing you do the pull, has anything changed up there? The second thing that you do is then a push after everything's settled, and you push it up there. So remember before I asked, what's the first thing that you do when you start a project? When you start a project, and most people said, we create a subdirectory. So how about this? Instead of creating a subdirectory, what if you created a repository on GitHub? It's pretty fast to do. It's really fast to do. You can also create the Readme file at the same time, so you can give it that great name, and you can begin to take notes right then and there. And then you can do the following. So now what situation are we in? We have this remote repo. We've started to do some work on it. We want to create a local repository based on that work. So what we want to have happen is we want to have a single step that we can take that would create a subdirectory and make a local version of that repo and create the files for us. That's called clone. So you start with a remote repository, and then you can make a clone, and we're going to cover exactly how to do this. And that will create a repository, and at the same time, we'll then reinstate those files. It will replay, and so it can create all the files that were indicated and that were part of that, that remote repo. Then when you're there, you can go and you can do that virtuous cycle where you're making edits, you're making adds, you're making commits, and then you can do your pulls, and then you can do your pushes. It's much easier to start when you start with that remote repo than if you try to start locally, then create the other one. There's just more steps to it. The other thing is that it kind of forces you to create the repo. Sometimes you're really tempted to just go and create that subdirectory. But if your work style is creating the repo first and making notes up there, you've already started the communication with others who might work on that repository, and you've also started down that road and made it easy for yourself to do good. All right, so let's go ahead and take a look at what we know here. So what is this part called? Go ahead and put it in chat. What is this green box here called? Yep, it's the workspace. That's right. So this is our workspace. And what do we have to put files onto before they can be committed? Yeah, before they can be committed to the repository, yeah, we need to have them staged. And what do we call it when we stage? What is the command? Yep, add. Absolutely. Okay, I've staged my files, and I've given a particular file name here. What do I call this right up here? What is the dark green box? Yes, this is our repo, our repository. And what is that? What is that? The action that we take? Yes, we do a commit. And Eva, yeah, you mentioned Git Commit. So when we actually carry these commands out on the command line, we don't just say add and commit. Instead, we have to let the system know that this is a Git command. So what we do is we say Git add file name, or we say Git commit and then -m and then some message. So just remember that it's always Git and then the action. All right, and what is this over here?
And we have a quick question.
Yes.
Farouk says, could you explain the -m in the commit message?
Sure, absolutely. So this is a parameter. This is modifying the action of commit. So if we said just git commit, it'd work, but then it would be a commit, it would take the snapshot, give you the hash, it would handle all that for you, but it wouldn't have that message that indicated why you did that. So the -m is a modifier for this action. And what it's saying is, take this text right here and attach it to the commit. And there are a bunch of these. It's one of the things that keeps people away from Git, frankly, is the fact that this has been used for how many decades now? 2 decades? Trying to think of when Git was around the creation of Linux, because they needed to have a way to have all these, this work being brought together. And as you might imagine, this is created by programmers who want to do lots of different things and want to save themselves as much work as possible. And so there are many, many different commands. There are many, many different changes that you can make to each of those commands using those modifiers. So remember, you don't need to learn everything at once. You don't need to know how to solve everything at once. You can simply start simple, start with the basic things that you need, and then go from there. So my suggestion is you start with the basics so you can do what you need to do. And then as you find that you need to do something else that isn't covered, then you go a little bit deeper. And we're going to be seeing exactly where to type all these in just a moment at the command line. All right, so what is this blue box over here? Yep, this is our remote repo. This is actually sitting this is GitHub. This is sitting in GitHub. So in addition to the remote repository being there, you have all the other nice things that we've talked about in the past for GitHub, where you have issues and you have the project and you have a way of seeing everything that's going on. All right, excellent. All right, let me go ahead and put a cheat sheet up for us. It's going to be small, but I'm going to create a cheat sheet for us to use in our conversation as we go forward. You can sort of use this to reference what we've done so far. Nope, not that one. I want to have, where did my, oh, here it is. Here's my cheat sheet. Maybe I'll make it big. And I'll just get out of the way when we need it. So let's go ahead and see what this looks like when you're running it. What happens is that really all of these commands that I'm talking about take place on the command line. If you've never used the command line, what you're used to is a user interface. So in Git, you can absolutely use user interfaces, and we're going to show you one in just one moment. But know that actually in the background of all these user interfaces, these commands are being issued verbatim to what's called the command line. And the command line is the text-only way of interacting with your operating system. We're not going to get into the details of all the other things that you can do with the command line, but suffice it to say that it's very powerful. You can create repeatable actions there. It's a great way to get at the full power of your operating system, and is probably a good thing to learn at some point in the future. What we're going to be using it for primarily, though, is Git for right now. But for right now, let's go ahead and let's take a look at how this looks when we use a command line. I'm sorry, when we use a GUI to do all of these actions. So now what I'm going to do is I'm going to show you R and RStudio. And what RStudio gives you is a nice graphical user interface for handling GitHub. So this is the RStudio interface. And what we're going to do first is, well, I want to start a project, right? So that's basically what I want to start a project. So what do I do first? Want to start a project, create the file, make the repo. Absolutely, that's it. You start with the repo. So I actually have a repo that I started about this workshop, as a matter of fact. It needs some work. I've got to add some stuff to it, but at least I made the start with the repo. So I'm going to show you what it looks like to create a repo. It's pretty straightforward. You go to GitHub, and you can click New, and then you can type the name, the description. You'll want to add the README, and we'll go through this again in just a moment. But just to put this in context, that's how you create the repo. And that's how I created this repo. I added some stuff in the README. But now what I want to do is I want to take that remote repo and I want to bring it local. So right now I have this, I've started with just this remote repo. Now I actually want to do that command where I draw it down. Does anybody remember what that command is called? That git command is called, so I can actually make this remote repo local. Git clone, that's it. They make this really easy. GitHub's make this really easy. So go to the big green button. It's almost always that you go to the big green button no matter what you want to do. And here's where you can clone. And what you want to do is you want to copy this right here. See this little icon right here that's a clipboard? You want to copy that. And then what we're going to do is for RStudio, and you don't have to do this, but I'm just showing you what it looks like in RStudio. I'm going to go to File, New Project. I'm just going to do this quickly because I want you to see what the GUI looks like. I'm going to do version control, Git, repository, and create project. We're going to do this all at the command line in just a moment. Create project. So notice what, oh, it went away. But what it did behind the scenes when it showed that window really quickly, it was doing a git clone. So all it's doing is it's saying everything that I'm pointing and clicking and doing a git clone for me behind. The other ones we'll be able to see a little bit more easily. So I'm going to go ahead, I'm going to edit the README. I'm going to say before the workshop, I'm going to say here is a copy of the video, because we are going to put the video and attach it right here. So I'm going to, so remember what I've done right here. So right now I've made this change in my workspace and I'm just about to save it. So I can't stage it unless I've saved it. So I'm saving it. Now what do I need to do? What's my next step? Yep, git add. Eva, you are on fire. I'll say we're going to do a git add. The way we do a git add here is we want to click on staged. And this is another one where you can't see it doing git add because it does it behind the scenes, but we click it there. Now it's been added. Now what do I want to do? I'm done with the work and I'm ready to move this up to the repo. Yes, I want to do a git commit. So I'm going to click on commit. And see, this is what I was talking about before. It can actually figure out the change from the previous work that was done. It's going to take a snapshot of everything, but it can easily show you, because of the way that it's stored, what's changed. It can show you that diff really easily. This is where I put my commit message. So I'm going to say, with this commit, I'm going to say indicate where the video goes. So what you don't have to do is to say, with this commit, I edited this file or added this line, because the repository can show you that, right? I mean, it's very clear. It's showing you right here what changed. So all you need to do is to say, why? Why did I do this? I wanted to indicate where the video goes. Right now I'm going to do a commit. It's going to do the commit a little bit differently, because you'll notice it has this big long space here. So what it's doing behind the scenes is allowing you to type however long you want. It's going to say, use this entire file as a message. I'll show you what that looks like in just one moment. So here we go. Here's the command that it sees. It says git. It puts the full git exec, but you won't need to. So you do git commit, and then instead of a -m, it says -f. So what it's doing there, where it's making a whole file the commit message, just to give you a little bit more flexibility. Messages are a little bit limited in the size that you can have, but just know behind the scenes, it's doing this for you. So I'm going to close. So that commit has been made. All right, so I've made something. So I've updated my repository. Now what I want to do is I want to actually communicate this change over to the remote repository. So what do I do now? Yeah, so I want to do a push, but actually I want to make sure that nobody else has made changes while I've been out. So I want to do what first, even before I do the push? Yes. So I'm going to do a pull, make sure nobody else has changed stuff that I need to sort of include in my work. And then let me ask you this, and give me, if you would, give me a thumbs up. Or give me a red check mark or a green in your reactions. Am I asking files to be moved down from the remote repository? Am I trying to get copies of the README file that I edited? Let me ask this as a true false. True false. I am getting a copy of the README file. So give me a red X for that is false, a green check for that is correct. Yeah, no, not exactly. Am I asking the two repositories to communicate what changes have occurred? Give me a red X or a green check. That's what we're doing. So we're not moving files down. We're saying repositories communicate. And what they're going to do is they're going to communicate the commits. So it's going to actually look and see what's changed, and if there's anything where we both made a change in the same file at the same time. So let's go and do this. I'm going to do a pull. It's right up here. I'm going to do pull. And look, Git Pull. That's the actual command line that we could type ourselves, Git Pull. Everything's up to date. We're good to go. I'm going to do a Git Push. And check this out, Git Push. Oh, except I'm using a second computer, which I usually don't use. So I have to put on my credentials, which I'm not going to do right now. So,
and just a quick question. Oh, sorry. Did you? Okay.
No.
Quick question. So some people are a little bit confused about how RStudio, so how this GUI relates with the command line and how it can be used with Python, and then how those things relate to GitHub.
Okay, great questions. So what we're seeing right here, and we're going to do the command line next right away. So I could have used any GUI for this. I just happen to choose RStudio because that's what I happen to be using at the moment. So this command that we can type, actually we'll type into the command line in just a moment. The essence of it is git push to origin, and that gets you where you need to go. So high level view, and we're going to go to the command line next. But the high level view is that you can do work with Git pretty much in a variety of GUIs or at the command line. So the exercise of what we just saw right there was that there are these GUIs that you can use, and all that's happening is that they're issuing command line, they're issuing commands for you under the hood. So let's go under the hood. If you go under the hood, then that means that it doesn't matter what language you're working in, or what whether you're using RStudio or Python notebooks or Java, or whether you're just doing editing of files, doesn't matter. If you go under the hood and if you do the work at the command line, it doesn't care what the files are. You don't have to be working in any particular GUI. So often when people are working in Python, they'll go ahead and use the command line. Can make things simpler. So Dr. Bell, you've worked with a lot of different projects. When you're using Python, what do people tend to use? Are they using GUIs or are they doing command line?
For me, I tend to use the command line. I think I have seen some people maybe use like a side GUI, but I think the command line, once you get to know it and with all the capabilities that are enabled through it, I think it's a great interface for working with Python. Yeah.
Great. Well, let's go and see what this looks like. So let's take a look and let's think about where we are right now. So we went ahead and we went through, we started with something remote. We did a clone, we brought it in here, and we went through a whole cycle here. We went through a whole cycle, and then we moved stuff back over to the repository. Let's go and do this again, but let's do this from the command line. So in order to do this again, I'm gonna just nuke my work. So I'm gonna go in, this was under projects, and when I did the clone, it created this nice subdirectory for me. Oh, come on, you. It created this nice, oh, okay, it's empty, wonderful. Oh, I have it stored someplace else. Okay, so what we're gonna do is we're gonna go up to our repository up here. We're gonna do the same thing that we did before. We're gonna clone, then I'm gonna go to my command line. I'm gonna get the location of the remote repository. I'm gonna go to the command line. I'm gonna do a clone and bring everything down. And then we're gonna go through a whole cycle of editing and then going ahead and pushing it up. All right, any questions before we do that?
And one quick question. So someone said that we keep saying GUI. What is a GUI?
That is a great question. So it is GUI, G-U-I, graphical user interface. And whenever everybody asks me about that, I realize it sounds like GUI, G-O-O-E-Y, or like Goo Goo clusters, which were invented in Nashville. So whenever anybody asks me that, I get hungry. It's sad, but it's true. But GUI actually refers to graphical user interface, which is not appetizing or unappetizing, but remember, it's only a front end for other stuff that's happening underneath the hood. So when we say GUI, it is that user interface that is given to people that simplifies or should simplify the work that's being done underneath. Great question. All right, so here we are up at this remote repository on GitHub. I'm going to click on the code and I'm going to copy the location. And if you look in here, what you're actually doing is you're copying the location of the .git file. Remember that .git file is the repository. That's everything that you need. You don't need all the other files. That .git is everything that matters. So I'm copying where that is. And now I'm going to go local. So I'm in documents. I'm in projects. And what I want to do is I want to create a command line. I want to go to the command line right there. So in Windows, you can do a right click and select Git Bash here. So this opens up this window. So this window may be very new to you. There are different commands that you will need to learn in order to work with these, but know that those Git commands will work here. We're going to type them directly in here, but here are a few additional commands that you will need to know. And if you don't understand them, if you need to dive in a little bit more, we'll have some resources for you to learn more about command line. But let's go and get a listing, ls, of all the files that are in this project subdirectory. And there's nothing. It's blank. So what I want to do is I want to do a Git clone of that remote repository. So I'm going to do Git Clone. And then what I want to do is I want to paste in that remote repository. So Git Clone, Git is this is the Git command, Git Clone. I'm going to run it. All right, great. So it had 10 objects apparently, tells me all this information about everything that was brought down. Let me get a listing of what's in my projects directory now. Okay, it created a subdirectory for me. And if I go up here to the graphical user interface and look here, you can see it there as well. So how do I move into a subdirectory? Up here in the graphical user interface, all you do is you point and you click, right? And then you're in it. Here, what you do is you do something called change directory. So I'm going to do a cd change directory, and I want to go to ws dash, and that's all I have to type. So one of the things that the command line gives you is it gives you a shortcut. You can hit tab, and that does an autocomplete. So cd says change directory to the basics. Now I'm going to get a listing of all the, notice where it says, it tells me where I am. I'm in documents, projects, Git basics. I'm going to get a listing. So I have two files in here. I have the license and I have the Readme. Great. Well, I want to edit the Readme just a little bit. I want to edit the Readme, and then I want to stage it, and then I want to commit, and then I want to do the pull and push. I want to do the whole thing. So let's do this. You don't have to do everything in the command line. You know, here's a Readme. I can just go ahead and I can edit this using whatever I want to. So I can, I'm going to open this with something simple. I really don't want to have to open. This is my secondary computer. It's going to have to open up. Oh, edit. Oh, thank you. Okay, great. Edit with Notepad++. Notepad++, if you've never used it, is great. It's it's a good thing. So here, this is that README file, and I can say, I mentioned the resources here. Command line resources include. And I don't have anything right now, but I'll put it in a little bit later, but I've changed it now. So I'm going to save my changes. Okay, let's go through here real quickly. So I'm here in the workspace. I've edited the file, but has anything changed in my workspace yet? Give me a green yes if you think the workspace has changed, or a red X no if you don't think the workspace has changed. Here's a hint. I haven't saved it yet. Yeah, you're right. The workspace is just the files, right? The workspace doesn't know that you've been editing away happily. So in order for the workspace to change, you have to save the file. So now I've saved the file. Now let's go back to the command line. So I'm going back to the command line. Listing the files doesn't tell me very much about what's going on. I want to know the status. Are there any files that have been edited that haven't been staged, or I want to know what's happening. Dr. Bell, what is your favorite Git command?
Git status.
Git status. Git status tells you what's up. So let's type Git status. All right. It says one branch, main. We'll talk about branches next week. So my branch is up to date with main, great. But I have changes not staged for commit. So it tells me I've modified readme.md, but I haven't staged it. So, and it even gives you an idea of what to type. It says, no changes added to commit, use git add. So Git Status actually will help you and tell you what you might want to do next. So I'm going to do a git add, and I'm going to do the name of the file, which is readme.md. Great. Now I'm going to do a git status again. All right. Now notice that it said modified and it's green this time. So it says changes to be committed. And it says you're kind of ready to go forward. So what's the next thing that I do here? So I've modified, saved it. So I've changed the workspace. Now I've gone ahead and I've added it to the staging. What do I do next? Yeah. Git commit. And not just git commit. What else do I need to do? It's got to be git commit -m message. Absolutely. And my message is going to be, so what did I do here? I included command line resources. And now I'm going to hit enter. And it tells me a couple of things. It tells me, notice that it labeled it here. So let's go ahead and do another git status. This is the last few digits of that hash. Remember I said that it takes a fingerprint? It's called a hashing function. It takes a look at all the files that went into this, creates what's called a hash. And while it's not doing any sort of a lookup to make sure that that ID number isn't repeated, the very nature of the hash function means that it is astronomically unlikely that you will reuse a number. So that hash is your fingerprint. It is the label of the change that you've made. And it reflects that compressed file, that compressed entry into the .git file that is all the changes that you just made. So let's do a git status. All right, on branch name, your branch is one ahead of the origin main by one commit. So what that means is, good for you, you've done some work, but oh, by the way, you're now ahead of this. So we want to fix that. So what do we do? What's the first thing we want to do to make that remote repository and put it in sync with our local repository? Yes. So we're going to do a Git Pull first, just to be sure that nothing has happened up there while we were busy editing away. So we're going to do a Git Pull. We're good to go. It's already up to date. There's nothing, which by up to date, that means nothing has happened remotely that we don't have locally. Something has happened locally that hasn't been moved up there, but that's different. With the Git Pull, it says, oh, you're up to date with what's there, nothing new. You have something new, but all of your previous stuff is up to date. So now we're going to do, what do we do next? Yep, we're going to do a Git Push. Absolutely. And we want to say that, okay, now I've forgotten. Dr. Bell, do I need to do origin? Can I just do Git Push? Actually, don't tell me, don't tell me. Nothing, Git Push. So Git Status tells me what to do. It says, go and do Git Push. I'm going to run Git Push. Oh, and it can't do it because I'm on my second computer and I don't have my credentials in here. All right. I'm going to go ahead and do that. So my credential for GitHub, and we're going to cover this too when you all do this in just a moment. So I need to look at my credentials. Well, actually, I'll do this real quickly. So my credential for GitHub is a little bit boring. It's simply my Gmail address. So it is jesse.spencersmith@gmail.com. And then it's asking me for my password. So I'm going to go ahead and do my password. I use, and everyone should use, a password vault. So I use, it is a great thing to use. So I use 1Password. And then you can have these long passwords that are randomly generated. So here's my password for GitHub. And I'm going to go ahead and put it right in here. You should only have to do this once. Excellent. So now that it had my credentials, it knew who I was, it knew that I had permission to go ahead and make edits up there. So it communicated the two and it pushed my changes up there. So now we've gone through a complete cycle. We have, we've started with the remote repository. We did a clone, we brought it in here. We instantiated all the files that just happened as part of the clone. Then we edited a file and saved it, thereby changing the workspace. Then we went ahead and we staged it. And then we went ahead and we made it part of the repo by making a commit. Then we did a pull to see if anything had changed. And then we did a push. So we've done the complete cycle altogether. Great. Are you ready to try it on your own now?
And I think we have a quick question about origin main. Someone asked, what's the difference between pushing to origin main and pushing to origin perhaps somewhere else, or maybe not origin, maybe different?
Do you want to answer this one, Dr. Bell?
Sure. So we will talk about this in our next workshop about branching. But if you're going, like, pushing to origin main is going to push to the main branch in your origin repo. You can also push to other branches. So you can push to origin branch 2 or origin dev. Even beyond that, you don't actually have to push to origin. If you fork from another repo, you can push to that other repo and a branch on that repo. So whenever you're developing by yourself, often you do push to origin main because you are writing directly to main, so that branch. But if you start to get into branching workflows, you tend to push to origin branch, which again, we will get into next week.
Mm-hmm. So this is a great example of there being a lot of power in Git and GitHub. You don't have to use everything all at once, but one of the big problems that people tend to have is how do you work together and how do you sort of keep your work separate until it needs to come together? Because, you know, every time you type a sentence, every time you change a little piece of code, you don't want to always be saying, oh, let me fix it with this other person. You want to have a unit of work that's related in some way. I'm adding a feature, I'm solving a particular problem, and when I'm done, I'm then going to look to see what's been happening at remote on a different branch. So branch should be mine, I get to do my work, and then when I'm all done, then I can go ahead and pull these branches together. And it's at that point when you do that work. One really good workflow is called Github Flow, and that's what we're going to be talking about next week. So it's not something you need to learn right away. First, you want to get the basics down if you're new to this completely. But then once you get the basics down, it will seem natural to go to branching after that. Great question. Other questions before we all right, one moment.
Sorry, I think I might have muted you a second there. I think you're back though.
Okay, great. Thank you very much.
Sorry about that.
Great. So questions before we get started. Does the Mac terminal work the same way as the PC? A little bit, yes. You actually have to get into shell, but it looks, once you get here, it looks very, very similar. Actually, yours is more full-featured than the Windows one. Yours is an actual Linux box underneath, whereas ours is just emulating certain parts of it being Linux. Okay, how does the Git diff checker work when deleting update 1 but not update 2, line by line? The Git diff doesn't delete. All the Git diff does is show you who did what. And it usually identifies, it can identify what branch the change came from, or it can identify by the name of the commit where the work came from. And it's up to you. So the Git, the Git diff can't tell what's important or how these two sentences ought to be combined or which piece of code wins. So that's something that you actually have to figure out. So that conflict you have to figure out. And we'll do that we'll touch on that next week when we talk about merging work. All right. What does Git checkout really do? Yeah, so the Git checkout, that is moving you to a branch. So we've all been working in main, but it turns out that, all right, I'll mention this just very briefly, but then we'll do it more next week. You can think of like a parallel universe. So imagine that you can create a parallel universe where you can try some things out. And if it works out well enough, you can merge it into the current universe, the main universe. That's what's happening with a branch. You get to try things out, change code, do lots of different things, and everything looks the same, except that when you do a Git status, it's going to tell you that you are not on branch main. It's going to say on branch solve issue number 21. And all the work that you do there doesn't interfere what's in main until you do what's called a merge. So that's kind of what it looks like. It's an alternative place where you're working. All right. Other questions? All right, then let's do something. So you all have projects, you all have things that you have in mind. You can also just make a fake repo if you want to, but we want to start a project. What is the very first thing that we're going to do when we want to start this project? Yep, we're going to create a repo. Absolutely. Oh, so I'm going to go to GitHub, and I'd like for you to go to GitHub too. So go ahead and pull up a browser, go ahead and go to github.com, sign in. And again, if at this point you don't have the GitHub username, you don't have Git on your computer, that's fine. You can also just follow along. I'm going to do something just absolutely crazy. I'm going to go ahead and create my repository for our workshop next week. Because I know that we have work in a couple of different places, so I want to pull all that work together into one place. So again, big green button, new. And our workshop next week is on Github Flow. And you want the name to be fairly short, but meaningful so you know what it is. In the description, though, you do want it to be more verbose. So workshop on GitHub Flow for Teams. You can make this public, you can make it private. I'm going to make this one private for right now because it's just a sample repo. You always want to add the Readme. That is a placeholder that you always want to have. You might recall the previous weeks we talked about what made a good repo. Readme is part of that. And you can also choose a license. You want to learn more about licenses. You want to think about licenses. If you don't have a license, either people won't use your stuff or they will use your stuff, but inappropriately. So add a license. And I'm going to go with, I'm going to choose the MIT license. And then I'm going to create the repository. Say, go and give me a green check if you've created a repository now. Excellent. If you have any technical difficulties, know that you can go into, I've opened up the breakout rooms. So you can go into a breakout room, go ahead and message directly to Dr. Bell or to Umang, let them know you'd like to meet them in the breakout room, but then you can elect to go into the breakout room with them. All right, what do I do next? Yep, I'm gonna clone it. And remember, big green button, you click on it, clone. So now I'm going to get the location of this brand new Git file that was created, gh.flow.git. I'm going to copy that. And now I'm going to browse. So I'm going to go back to my projects. And I'm going to go ahead and I'm going to do a git bash here. So I'm going to get a directory listing just to see what's there. So I have my other one that I created, the workshop Git basics. So now I'm just going to do clone. Oh, I made a mistake here. What mistake did I make? Yeah, it's Git clone. I do this kind of frequently. I think other people do too. You just think of the command part, not the Git command part. So you've got to do Git clone. And then what I do is I just want to paste in that URL. Oh my, I made it private. Why did I make it private? Okay. Because I made it private, I've got to make sure that it knows my credentials. And then it's going to ask me for my password again. Luckily, I have it open right here. Okay. A fair question is, so now it's fixed. And if I do a list, I can get a listing of the files here. And now I have a subdirectory that's called Github Flow. So fair question is, do I always have to type in my, my username? And the answer is actually you don't have to every time. So you can actually put these in using a command. And actually here, let's go ahead and go to the repo because it is in there. So if you go to the Git Basics repo, it says setting up Git. The very first thing you should do when you install Git is to set up your username and email. Oh, it looks like the formatting is wrong here. But you do git config -- global, your username, and then your name, and git config -- global user email. So I'm going to type those in right here. So I'm going to do git config -- global. This means I don't want it just for this repo. I want it for every time that I get into GitHub, that I get into Git. It's going to do this thing. And it's user.name. And I'm going to actually use just jesse.spencersmith@gmail. Okay. And then we can also give it a git config -- global user.email. And I'm using my same name and use just for both, smith@gmail. Oh, I messed up the previous one, didn't I? You can use up arrow to go back and resubmit a command. Okay. So that'll save me from having to do some of that at least. All right, so let's take a look at the subdirectory again. We have GitHub Flow, cd github -flow. Oh, and do you remember what the shortcut is? So if I don't want to have to type all of that, I can start typing github What's the shortcut I could use to do an autocomplete on that command? Tab, exactly. There we go. And notice that it changes. Because this is actually Git bash, this means that it's actually GitHub enhanced, that it's Git enhanced. It tells me what branch I'm on. So it tells me where I am and what branch I'm on. I'm in a directory. So it has the README, it has the license. Let's go ahead and do an edit of the README. So remember, you don't have to do the editing here in the command line. That would be painful. You can use whatever kind of editor you want. So let's go and go to the Windows browser. We're going to go into projects. And then we're going to go into Github Flow. And then I'm going to edit the README. And I'm going to be using Notepad++. So this is what the README has in it. And I'm just going to say, GitHub for Teams. I'm just going to say put graphic for GitHub Flow here. This would actually probably be an issue, but I'm just going to put them text right here. And then I'm going to save it. Now here you can tell I've just done an edit, date modified, 1244. I go back to the Windows command, I go back to the command line. How do I tell what the status of everything is? Git status. Notice that it put the README in red. So how do I go ahead and add this? How do I stage this? Yep, git add readme.md. And then do I do git status again? And now it tells me that I am ready to commit. And we do git commit -m. And this is going to be include GitHub Flow graphic. So what have we done so far? We've created our remote repo. We did a clone. We edited the file and then saved it. We staged it. And now we are ready to do, we just did our commit. So now I'm going to go ahead and communicate with the remote repo and make sure nothing's happened up there. So I'm going to do a Git Pull. We're going to pretend we did a Git Pull. Well, there are extra steps that you can take where your credentials are stashed. We're not going to cover that right now, though. And okay. All right, and which one? Oh, Git Basics. Oh, GitHub Flow. This is the one that we're working on. We're not working on this one right now. Okay, great. It is already up to date. Now I can do a Git Push. And I'm just not. This is a problem that I will have to solve a little bit later. Okay, great. And now I've done the push. All right, so if you were following along, you have now created a remote repository. You've cloned it, you've made it local, and you've gone through all the steps using just basic command line. Even if this is the last time that you use command line, at this point going forward, you use GitHub you use graphical user interfaces, GUIs, understand that this is what's happening under the hood all the time. So those basic commands, remember this workflow, this is what's happening, and that you're almost always communicating with the repository and having the repository communicate with the remote repository. And you can do some pretty advanced things. Sometimes the advanced functionality is only available if you do it at the command line. So it's a worthwhile skill to have and something that you might want to fall back on, especially if you're using Jupyter notebooks. So I'd like to open this up for questions now. What questions do you have about Git, GitHub, or that workflow? Yeah, so you can use git merge to merge the current branch with the main. You can specify exactly what you mean, because you could merge two different branches that are not main. So there are always defaults that a git command will have. But if you want to be very explicit and clear about what's happening, you can specify them. So you'll notice that in when I was using the R Studio GUI, it sort of spelled everything out. So it was very, very verbose, and it spelled everything out, which is a good practice. Other questions? Rebase. Dr. Bell, you want to talk about this one a little bit?
Sure. So I see, Chris, where you said you're seeing pull options for rebase, true, false, or fast forward only. These are different ways of combining the code from whatever branch to your new branch. So it's just a way of kind of arranging the commits, whether you stack them or whether you merge them together. And rebase is going to try to stack them.
So the idea there is that some people don't like to have all the different commit messages sort of all available. I think in data science, we probably prefer to see them. I think that we prefer to have everything visible. So when you do the merge, it's almost like it just sort of puts them in place. So that's often what you do when you have an analytical workflow or data science workflow where you want to go back and see what happened. It's not like, oh, it worked, now you want it to go away. Which maybe you may want to do in software engineering. It's kind of like, I don't care what all the intermediate work was. It worked at this point, passed all the tests. Therefore, I can make all the commits go away. Then it's kind of safe to do that. But here we're not running tests. We're evaluating code when we do merges. We'll talk about that next week. But long story short, you want to keep those commits when you have an analytic type workflow. When working on a remote server that does not connect to the internet, ooh, are you with the NSA, Amy? Is there a simpler process to using Git versioning other than manually downloading code files and then committing to GitHub? I'm unsure. Why don't you hang around, Amy, and then we'll see if we can't sort of figure out what the issue is. Good, interesting issue. And Chris is asking, is rebase true, the collapsing method? I don't remember. I will have to look that up. Yeah. I think that fast forward is the collapsing, but I'm not sure. I'm gonna have to check. What are branches? Are they like snapshots to your work? Different codes are part of the repo? Good question. If you think about it, each time you make a commit, it takes a snapshot of everything, right? So really what's happening is, what are you pointing to? And where is your work going to be going? So we'll have some graphics next week that will make this a lot clearer, but it really is, what are you pointing to right now? What is the current state that you're pointing to? And it all has to do with how they're arranged, what order they're arranged, that can give you different branches. So my short answer to that is, come back next week. If Git Pull does reveal that you are not up to date before you do Git Push, what do you do? Well, remember, Git Status would be the one that would reveal that you're not up to date, and then Git Pull would pull it down. And if there are no merge conflicts, you're fine. It'll just roll everything in. If there are merge conflicts, then you have to deal with those. We don't have time to talk about those today, but we will definitely be talking about them next week. I second Edward's question. What was Edward's question before? Do you see Edward's question?
I think it is that question that they.
Oh, just that question. Okay, all right. Can we use Dropbox or other cloud sync folders for our projects? So here's what we do. We use Dropbox for data files. So we'll do it in a couple of ways. One, like the most secure way to do it is you actually access Dropbox using the API, and then everyone has local copies of their own credentials. And in the code, what we put in there is here's the code for the API. Put in your credentials or cache your credentials locally so you can pull that data in. And then we use Repo, we use a GitHub for all the code and for a little bit of the data, like the lookup files that don't have any sensitive data, that are small, that everyone's always going to need. It's kind of a pain to have to like go to Box and then to get a lookup file. So those we version, but they have to be small, and they're sort of, lookup files tend to be sort of tied closer to the code. So that's our reasoning for that. Anything which is large, anything which is secure needs to be stored in a secure location, and that is not GitHub. Well, one of these trainings show how to tie to external data boxes. We've had a couple of questions about this. So yes, we will do it over the summer because we're kind of filled up for this semester, but we will absolutely add one in on how to tie into Box, Dropbox, and RedCap. All right, other questions? All right, I'd like to thank everyone for your time. I'd like to remind you, of course, that we do have other workshops coming up. I hope that you'll be able to join us for those. Just as a quick reminder, the workshops that we have coming up are, I'll share these here. So the workshops that we have coming up, I'll go all the way up to the top. Oh, looks like my share is not working. So the other workshops that we have coming up, next week we have Github Flow, and then we have other workshops around data science, running data science projects and code there as well. And we'll be sending out emails. Please go ahead and follow us, our activity on Eventbrite, and you'll be notified whenever we have new workshops that come up. Thank you all very much. Hope you all have a great day. Thank you, Andrew.